Hello, our team is formed by Daniela Palacios Trejo, Valeria Tolentino Lopez, Angela Vera Cervantes, and Ramiro Encantu Ayala, and we're presenting electric charges and currents.
Static electricity. The electricity trapped on the surface of a non-conductive body is referred to as static electricity. Electricity on a conducting body in contact with only non-conductors is also prevented from escaping, making it neither mobile nor static.
Electric current. Electric current is the amount of energy, usually measured in amps, that is running through an electrical current. The more amps, the more energy is flowing to an object. It's easy to think of it like a river that runs in one way. Electric current is usually shown in a graph that's kind of like a box with a battery that's positive and negative. The positive and negative outputs are because something like a light bulb needs that to actually work, because something that cannot run only on positive energy. It also needs to a place that it can throw away the negative energy that it has. Magnitude. Magnitude is better defined as the distance or quality of an object and the direction that said object can travel. It's used to describe the extent that an object has in size or distance. Magnitude is kind of a different thing to electrical current, and it's kind of difficult to explain, as magnitude is more than anything just the qualities of an object and how far an object can be thrown or pushed around. So the magnitude can be used to describe the size and how the forces will affect the object in the future, if said forces are going to be acted upon in the future.
For a charge to flow, in order for it to be used as a power for a device, it must be flowing around a loop, a closed path, otherwise called a circuit. To be a circuit, it must include a source of electricity, like a battery, and a conducting material, meaning usually a cable. All this in an arrangement that forms a loop. As my teammate will explain, conductors are what helps electricity flow. In the case of a circuit, these materials tend to be covered by an insulator for efficiency and safety reasons. In the standard cable cord, the wire itself is made out of copper, which is a cheap conductive material ideal for the purpose of a cord. This wire is then covered by a thin layer of rubber material, which prevents the wire itself from coming into contact with other conductors and losing energy that way, as well as keeping the wire itself safe from the elements and the dangers of the outside, as well also as to keep it itself from being a danger to others and ourselves, so it's touchable without any sort of danger.
Well, now we're going to talk about conductors and insulators. An insulator is a substance or object that blocks or decreases the flow of electrical or thermal currents. Some examples of insulators are like rubber or silicone or plastic, the ones that don't let electrical currents keep going. And conductors, there are substances or materials that help electricity flow easily. For example, some examples of good conductors are metals. Yeah. Voltage, current, and resistance. Voltage is the representation of electric energy per unit charge. Current is the rate at which charge flows through surface, and resistance is a measure of opposition to current flow in an electrical circuit.
Ohm's law. Ohm's law is a formula named after German physicist George Ohm that is used in electrical circuits to calculate and describe the relationship between voltage, current, and resistance. This formula consists of E equals I times R, meaning voltage equals current times resistance. An example of how this subject is applied in everyday life is that electric current, we use it literally for everything. Since electricity is a need for us in our daily basis, like when we use the lighting, when heating food, when cooling food, in refrigeration, in charging our electronic devices, or for machines used in different industries, and even for public transportation and some cars.
So here's a short problem of what we would see with this topic. It involves Ohm's law, which is the relation between the current, the voltage, and the resistance. So here it's a simple problem of calculating the voltage if the current is 5 amps and the resistance is 3 ohms. So the first step, as always, is to write down the data. Here it is, you can see it. The step 2 is to write down the information as a variable and then the formula. So on the top here, we have the triangle, which shows the relationship between all these elements that form the Ohm's law relationship. So here we can very clearly see that to find the voltage, we need to multiply the current by the resistance. So the next step is to replace the values in the formula with the information we wrote down in step 1. So here it is. And step 4 is to get the result and add the required unit for the answer. In this case, because it's voltage, the answer is in volts, 15 volts.